problem here, I need to find my six-pack. Sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. Now, I already know that tangent theta is 12 over 5, so I could just fill that one in right now. So I'm going to give you a methodological tip, although this didn't cause too many problems. I know that tangent is positive, right? So all students take class. So tangent is either going to be in this quadrant here, or it's going to be in this quadrant here. Those are the only two quadrants where tangent can be positive. But I know that sine is negative. So sine is positive in quadrant 1. So I know that I am going to have my angle in quadrant 3, and I'll just kind of draw it in right like that. It doesn't really matter what it looks like. But once I figure out what quadrant it's in, then a good thing to do is this, is to fill in where you're going to have negative signs. Now your negative and positive signs are all taken care of. I got positive tangent, I have negative sine and cosine. So I don't need to worry about that anymore. Okay. Now, the biggest problem on this question was thinking that this is a unit circle. It is not a unit circle. One thing, it doesn't say that it's a unit circle. And I'm going to try and make a little video on this. I think it's going to be called "When Do I Use the Unit Circle?" Because it gets a little bit confusing. But the unit circle is only when the hypotenuse is 1. And when I'm drawing a circle, let's just pause this here for a second. And let's look. When I'm drawing a circle, when I'm drawing a circle to make my angles, wherever I put a radius, and from that point on the unit circle, I drop my perpendicular down to the x-axis. I think everybody's gotten pretty good at that. That makes my right angle. The radius is always the hypotenuse of that triangle, no matter where I draw it. If I draw it down here, and I draw my little perpendicular, the radius is the hypotenuse. If I draw it in this quadrant, the radius is the hypotenuse. No matter what quadrant I draw it in, the radius is going to be my hypotenuse. And the reason that we like the unit circle is because the hypotenuse is 1. And we know that TOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So if the hypotenuse is 1, then all I really need to be worried about is how big is the side opposite and how big is the side adjacent. And that corresponds to the x and the y values. But this here is telling me that my tangent is 12 over 5. So the big mistake that was being made was somebody say, well, let's see here. If tangent is sine over cosine, which it is, right? They were saying, well, then sine is equal to 12, because tangent is 12 over 5. And then they'd say that cosine is equal to 5. The problem here is that it's not a unit circle. The hypotenuse isn't going to be 1. Am I making sense? Is there a question? Can I ask the question, Peyton? I see it.
No, why isn't it?
Why isn't the hypotenuse going to be 1? So, so the question is, why isn't the hypotenuse 1? So let's just make a right triangle here. I don't have any particular angle measurements on it, right? If the sine is 12 and the cosine is 5, and we say that those are the sides of the angle, right? How is it possible that my hypotenuse could be 1? The hypotenuse is always the longest side of a right triangle, isn't it? I mean, always. It has to be. It's opposite the largest angle, right? So I couldn't have if sine is the ratio of opposite over hypotenuse, it couldn't be a ratio of 12 over 1, because that would be saying that my hypotenuse is smaller than one of the legs of my triangle. Does this make sense? I mean, I had a lot of trouble grasping this when I first started studying this as well, right? But is it coming a little bit more clear here? Right. Now, for everybody who wrote sine equals 12 and cosine equals 5, I put a question on your paper, and I said, what is the range of sine? In other words, what is the minimum value for sine, and what is the maximum value for sine? Now, sine is opposite over hypotenuse. It is a ratio of two sides of a right triangle. It is a ratio of the side opposite our angle to the hypotenuse. What is the maximum value that sine can possibly have? Hannah?
Negative 0.0000, right? Because it's sine is less than 0, so any number over 0.
Yes, you are correct. In terms of absolute, in terms of absolute value, the lowest it could possibly be was 0. But actually, because we look at it on an xy axis, what's the lowest value sine can possibly have? It can be lower.
Oh, the lowest possible. I thought you said the highest.
No.
Negative infinity.
No.
Oh.
No. So now I'm going to press you on here a little bit, okay? I'm sorry. Yeah, let's just. I want the ratio of. So this 1 is wrong. Everybody agree that the 1 is wrong, right? It can't be. Okay, so that can't be right. Okay. So let's make a really, really skinny triangle, right? There's my right angle, right? What do you think this ratio is approaching? What happens if I make it even? I'm going to press it here a little more, right? I'm going to make it even skinnier. Man, that is really a skinny triangle. Okay. All right. So if I put the value of sine over the value of the hypotenuse, what number is that approaching? No. No. If it's really like a nice base on the triangle, you can see it's kind of a low number here, right? But now this is growing. It's getting closer and closer to the size of my hypotenuse. That's right. That's exactly right.
Okay. Yeah. Oh.
The closest it can be, the closest the side opposite can be to the hypotenuse is the size of the hypotenuse, which essentially makes our triangle disappear, right? You follow what I'm saying here? Right? So the maximum value that sine can possibly be is 1. And the minimum value that sine can possibly be would be negative 1, and that just means it's on the other side of the x-axis. Yes, Hannah.
Well, is that just for this is just for in problems, like problems in general, or is it for this specific problem?
This is for problems in general.
Oh, I thought we were doing, Okay, that's why I was, okay.
Oh, okay, I see what you mean, okay.
I
So-
thought we were talking about this one.
No, this particular problem, no, we're not
No,
talking about this
okay.
particular problem. Right. In general, the maximum value of sine, the highest it can possibly be is 1, and the lowest it can possibly be is -1. Okay? So that's why if you write sine as 12, the bell should be ringing off, because it can't be 12. The maximum value of sine is 1, and the minimum value of sine is -1. Is this making a little bit more sense? Yes? Okay. So when I see a tangent of 12 over 5, it's still sine over cosine, right? But I have to figure out what is sine and what is cosine, and then I can make a little triangle. A 5, 12, and I know that the hypotenuse of a 5, 12 is going to be 13. It's a 5, 12, 13 triangle. And I would find that by the Pythagorean theorem. I would go 5 squared plus 12 squared is 25, plus 144 is 169. That's equal to c squared. So c squared equals 169. C equals 13. That's the square root of 169 is 13. 5, 12, 13. Ask the question. Do you see it?
Yeah.
Okay. So sine in this problem here is opposite, which is 12, over the hypotenuse, which is 13. Then cosine is going to be side adjacent over 13. And then the rest of my six-pack is just flipping those upside down. So I have -13 twelfths, a -13 fifths, and +5 over 12. Yes?
I'm trying to see if I wasn't paying attention, but going back to the triangle,
Yes.
when you did the Pythagorean theorem,
Yes.
did, you added the opposite and the adjacent together, and you already made the assumption that 13 is going to be the hypotenuse.
Well, I kind of did it a little bit backwards here. I mean, I kind of knew that 13 was going to be the hypotenuse, but how did I know that? So I knew that the tangent, so that here's my angle, right? And I knew that the tangent is opposite over adjacent. So the tangent is 12 over 5. Okay. So that is going to be the ratio of the side opposite to the side adjacent. Now, my actual sides could have been 24 and 10. It would still give me the same tangent, right?
Mm-hmm.
Right? Or they could have been 48 and 20, and it would still give me the same tangent, because it's the ratio of the side opposite over the side adjacent.
Mm-hmm.
So I want to figure out what the hypotenuse is, right? So I know that this is side A, that's side B, that's side C. So according to the Pythagorean theorem, a squared plus b squared equals c squared. So I'm trying to figure out what that value is. So 5 squared plus 12 squared is going to equal c squared. 25 plus 144 is 169. I take the square root, I get 13. Is that good? Okay. How are we with that? Yes? Everybody okay with that? Okay. Was that